Okay, so what we want to do, we want to look at a little review. So we are going to simplify the following. So with this one, it's already simplified. So this is negative 7w minus 34. There isn't anything we can do for that. Now, I want you to know that negative 7w minus 34 is the same as negative 7w plus negative 34. And then we can rewrite this negative 7w minus 34. Okay. Now in this one, we can remove parentheses. 4 times 2y, 8y minus 4 times 2, which is 8. Now this is subtract 3 times y, which is 3y, 3 times 5, which is 15. 8y minus 8 minus 3y, and then minus 15. Okay, and we want to go back and look at this one again and look at it a different way. So now we want to look at like terms. 8y, negative 3y, negative 8, and negative 15 are numbers. So what we're going to do, we are going to take the subtraction and rewrite it. Okay, so we're going to take this subtraction and rewrite it. So to do that, so this is 8y, the definition of subtraction, add the opposite of what's being subtracted, plus negative 3y plus negative 15. Okay. Now, because everything is plus, I am going to put everything together that are like terms. 8y plus negative 3y plus negative 8 plus negative 15. And what I'm going to do, all right, and so now I'm going to combine 8 plus negative 3, which is 5y. Negative 8 plus negative 15 is negative 23. So plus negative, add the opposite. That's the definition of subtraction. So the answer is 5y minus 23. Okay. All right, let's look at another review. And this is solving an equation. So we want to simplify, isolate, and divide. All right, so we simplify. And what that means is we remove the parentheses. Let me get Miss, hold on just a minute. We need a little light here. Now, that's better. Okay, so we're gonna remove the parentheses. We're going to add like terms on the same side. So let's remove the parentheses. 3 times x is 3x minus 3 times 8 is 24 minus 13 equals 4 times 2x is 8x minus 4 times 7, which is 28, plus 24. Now, I want to make sure that I keep my sign straight tonight because I did make a mistake last week. So 3x minus 24 minus 13. So now that I have removed the parenthesis, I want to add like terms on the same side. So let me rewrite this. 3x minus 24 minus 13. 8x minus 28 plus 24. Okay, I think that I've written everything correctly. So this is 3x plus negative 24 plus negative 13 equals 8x plus negative 28 plus 24. So you owe 24 and you borrow 13. So you're in the hole $37 equals 8x. Now you owe 28, but you only have 24, so you're in the hole $4. All right, so this is 3x plus negative 37, 8x plus negative 4. Okay. All right, plus opposite means to subtract. So I'm going to change this back. And now after I have simplified, I'm ready to isolate. Now isolate means to put the variables on one side and the numbers on the other. So I'm going to subtract 8x from both sides. Now, if you recall from last week, I said that if you don't put the variables on the side with a higher coefficient, then your numerical coefficient is going to be negative. So it's going to be negative here. So that's negative 5x minus 37 equals negative 4. That's okay. All right, now I am going to put the numbers on the other side. So we undo this, add 37. We get negative 5x equals 33. And now the final step is to divide by negative 5. So x equals negative 33 fifths. Okay. So I hope this is helpful. This is review information. Okay. All right. So let's look at what we're going to do tonight. We're looking at fractions tonight. And so we need some introductory concepts before we do anything with our fractions. So the first thing we want to talk about is an even number. So an even number is a number that ends in 0, 2, 4, 6, and 8. Okay? 0, 2, 4, 6, 8. Odd number. A number that is not even is said to be odd. Now, when we talk about even and odd numbers, we're talking about the whole numbers. Okay, so the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, etc. So an odd number is a number that is not even. And so 1, 3, 5, 7, 9, 11, 13 would be the odd numbers. All right, the next concept we want to look at divisibility rules. Divisibility rules helps us to determine whether a given number would divide another number. So 2, is a number divisible by 2? A number is divisible by 2 if it is even, meaning it ends in 0, 2, 4, 6, and 8. So if a number ends in 0, 2, 4, 6, 8, it is even. 3, a number is divisible by 3 if the sum of the digits is divisible by 3. So here's an example. Okay. the question is 423 divisible by 3? To determine that, I take the digits in 423, which are 4, 2, and 3, and I add them together. When I add them together, I get 9. Since 9 is divisible by 3, 423 is divisible by 3. So let's show that. So 3 into 423. 3 we divide 4 one time 3 is 3. Let's subtract 1. 3 down by 2. 3 we divide 12 4 times. 4 times 3 is 12. Bring down to 3. 3 divide 3 one time 3 gives me 3. And the remainder is 0. So that shows us that 423 is divisible by 3. Now, the beauty of this is that we don't have to do all of this long division. We can just use our divisibility rules. Okay. All right, 4. A number is divisible by 4 if 4 divides the last 2 digits. So here's an example, 789. Okay. 4 would not divide 789 evenly. Therefore, 4 does not divide 789. 924. So the last 2 digits are 24. 4 divides 24, which are the last 2 digits. Therefore, 4 divides 924. So let's show that. So 4 going to 9, 2 times 4 is 8. Subtract 1, bring down my 2. 4 divides 12 3 times 4 is 12. Subtract, bring down my 4. 4 divides 4 one time 4 and 0. So this, this is a very shortcut because we can immediately see 4 dividing 424. All right, 5. A number is divisible by 5 if it ends in 0 and 5. This is one that we already know. Okay, 10, 20, 30, 15, 25. 6. A number is divisible by 6 if it is even and if it is divisible by 3. That's interesting because if a number is divisible by 3, that means 2 divides it. And if it's divisible by 3, so 2 times 3 gives us 6. Okay. So let's check this out. 56. Is 56 divisible by 6? It is even because it ends in a 6. Is the number divisible by 3? A number is divisible by 3 if the sum of the digits is divisible by 3. 5 plus 6 gives me 11. And 11 is not divisible by 3. Okay, so therefore this number is not divisible by 6 because it is not divisible by 3. It has to be divisible by 2 and 3 for it to be divisible by 6. Okay. All right. Let's see. Is 234 divisible by 6? All right. 234 is even. Okay, because it ends in a 4. The digits are 2, 3, and 4, and the sum 2 plus 3 gives me 5 plus 4 equals 9. 9 is divisible by 3, so 234 is divisible by 6. Let's test it. All right, 6 will divide 23 3 times. 3 times 6 is 18. Subtract 13, subtract 8 would be 5, 4. 6 will divide 54 9 times. 9 times 6 is 54. So 234 is divisible by 6. 9. A number is divisible by 9 if the sum of the digits is divisible by 9. So notice that 3 and 9 have the same divisibility rule. The sum of the digits have to be divisible by 3. The sum of the digits have to be divisible by 9. So here is one that I want you to fill in. I want this number to be divisible by 9. Okay. So the digits are 3, 4, and 5. So therefore we have what? 12. Okay. So what numbers added to 12 will make this divisible by 9? So let's see. So if I add 9, if I put a 9 here, okay, that gives me 21, but 9 would not divide 21, okay? Let's see. If I put a, well, this is, we already have 12. So if I put a 7 here, let's see, what am I trying to get? 9? Yeah. So we got 12. Okay. So 18 is divisible by 9. Is that correct? Okay. And then let's see. 27, 36. 9 is divisible by 9. Okay. All right. So in order for me to, I already got 12. In order to get 18, I could put a 6 there. Okay. All right. So 3, 4, 5, 6, which gives us 7 and 11, which is 18. Now, is there a way to get 27? I already have 12. I can't put 2 digits there. I cannot get 36 because you can only put a single digit there. Okay, so therefore 3, 4, 5, 6 would do that for us. Okay, if you put a 0, that won't work. If you put a 1, that won't work. 2, 3, 4, 5, 6 will work. Okay. All right, 10. A number is divisible by 10 if it ends in 0. This is an old standard. We know this. So let's review. A number is divisible by 2 if it is even, meaning it ends in 0, 2, 4, 6, 8. A number is divisible by 3 if the sum of the digits is divisible by 3. A number is divisible by 4 if 4 divides the last 2 digits. A number is divisible by 5 if the number ends in 0 or 5. A number is divisible by 6 if it is even and if 3 divides it. Okay. A number is divisible by 9 if the sum of the digits is divisible by 9. A number is divisible by 10 if the number ends in 0. So this is just a little test here. Is 435 divisible by 5? Is 435 divisible by 5? We would have to say yes because it ends in a 5. Okay. All right. So let's talk about factors. Okay. We want to talk about factors. Okay. So when we talk about factors, we are multiplying. Okay. We are multiplying when we talk about factors. So if we want the factors of 28, okay, that means we want all numbers that multiply to equal 28. Okay. Now, the easiest way to do this is to put them in pairs. Okay. You want 2 factor pairs to get 28. We want all the factors of 28. And so how do you do this? You do it by counting. Okay. And what do I mean by counting? Let's start with 1. Okay. 1 times what will give you 28? 28. Okay. See how that's done? All right, let's go to 2. Now, this is where you will use your divisibility rules to help you, okay? Will 2 go into 28? Yes, because 28 is even. 2 times 14, okay? All right, let's go to 3. Now, 3 would not divide 28 because the sum of the digits is not divisible by 28. Let's go to 4. We know 4 because 4 goes into 28 7 times. We know our multiplication table. So 4 times 7. All right, let's go to 5. 5 would not divide 28 because it doesn't end in 0 or 5. 6 would not divide 28 because 3 doesn't divide it. We already got 7, and then we go up to 8, and then we go up to 9. So the question is, how do you know how many factors this number has? And later on, I'm going to show you a little trick to help you determine if you have all the factors of a number. Okay, so we are multiplying. All right, we've already talked about that. Now, let's talk about prime numbers. Okay, so a whole number greater than 1 that has only 2 factors, 1 in itself, is said to be a prime number. And so here's this word factor. A factor is something that's being multiplied. For example, 2 times 3. 2 is a factor. 3 is a factor because it's being multiplied. Suppose we had this. 4 times x. 4 is a factor, and x is a factor. So if it's being multiplied, then it is a factor. So we want to find the prime numbers up to 100. Well, let's do the prime numbers up to 50. Okay, we want to do the prime numbers up to 50. So we know that a prime number is a whole number greater than 1 that has only 2 factors. So the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, etc. And so I have a little table here. Okay, so I'm going to cross out 1. Okay, so I want the prime numbers up to 50. So here's my dividing line. Okay, so the first prime number is 2 because it only has 2 factors. So once I get 2, I'm going to go through and cross out all other numbers that 2 divides. Why would I do that? I would do that because a prime number can only have 2 factors. So if I have a number that 2 divides, that means it's going to have more than 2 factors. It's going to have 2 and then the factors for itself. So I'm going to cross out 4. Now there's a pattern to this. Okay, if I'm starting with 2, 1, 2, so every second number I can cross out. Now all these numbers are divisible by 2, which means they have more than 2 factors. For example, let me show you because I don't want to carry too fast. Let's take, I crossed out 4. So the factors of 4 are 1, 4, and 2. See, a prime number can only have 2 factors. So 4 has 3. All right, let's go to 6. 1, 6, 2, and 3. See, it has 4 factors. This is why we have to cross it out, okay? All right, let's go to the next number, which is 3. 3 is a prime number because it only has 2 factors, 1 and 3, which is itself, okay? So it's prime. So the same thing that I did with 2, I'm going to cross out every third number. Now, some of these will be already crossed out, and that's a good thing. 1, 2, 3, 1, 2, 3. This is a new one. 1, 2, 3, 1, 2. This is a new one. 1, 2, 3, 1, 2, 3. That's a new one. 1, 2, 3, 1, 2. That's a new one. 1, 2, 3, 1, 2. That's a new one. 1, 2, 3, 1, 2. That's a new one. 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. All right, let's go to 5. We know 5 is prime, only has 2 factors, 1 and 5. So you get the drill. I'm going to cross out every 5th one. Okay, some are already crossed out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, let's go to 7. 7 has only 2 factors, 1 and 7. So I'm going to cross out every 7th one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Got that one. All right. Let's go to 11. 11 is prime. And so you might can already see what's going on here, but let's see. So I'm gonna cross out every 11th one, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice this diagonal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. That's it, okay? All right, 13 is prime. So we're gonna cross out all numbers that 13 will divide, okay? So that's every 13th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I think that we have all of the prime numbers. So I'm going to write them out. Okay. So we got the prime numbers between 1 and 50. So that's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. So these are the prime numbers between 1 and 50. So anything that you work, you should be able to work it out knowing that these are prime numbers. Okay. So here they are here. Okay. 41, 43, and we went up to 47. These are the ones less than 100, but we only went up to 50. So you should be able to do something here. Okay. Now, there might come a time that you're working with some numbers and you want to know, is this number prime? Let me show you a little trick that you can use to see if this number is prime. So is 89 prime? So what you do is take the square root of 89. You just do that on your calculator. Okay. So I got 89 square root. And the square root of 89 is 9.43398. Okay. That's what the square root of 89 is. Okay. All right. The next thing we do is we're going to list the prime numbers less than the whole part. This is what we call the whole right here. So list the prime numbers less than 9. Okay, so the prime numbers less than 9 are 2, 3, 5, 7. Those are the prime numbers less than 9. Okay, now will these prime numbers divide the given number? The given number is 89. Okay, so will 2 divide 89? No, because 89 is not even. Will 3 divide 89? Okay, let's add up the digits. The digits are 17. 3 would not divide 17. Well, let's do this in a better way. Okay, let's do it like that. All right, so let's see. Will 2 divide 89? No, because not even. Will 3 divide 89? No, because the sum of the digits is 17 and 3 does not divide 17. Okay. All right, let's continue. Three. Will 5 divide 89? No, because it does not end in 0 or 5. And then finally, will 7 divide 89? Now, we don't have a divisibility rule for 7, but we can just divide it out. So let's just see. Seven into 89. 7 to go into 89 one time 7 is 7. Subtract 19. 7 and 19, 2. 2 times 7 is 14. Remainder of 5. No. Okay. So based on that, no. 7 will not divide 89 evenly. Okay. Therefore, 89 is prime. Okay. Now, that's how you determine if the number is prime. Otherwise, you can just be spinning around in a circle trying to determine if the number is prime. All right, good enough. So we have, let's review. Goodness, we've talked about a lot of stuff. We talked about even and odd. We talked about divisibility rules. We looked at all of the divisibility rules. We talked about a factor. So even, odd. We talked about divisibility rules. We talked about factors. We talked about prime numbers. And then we looked at a little trick to determine if a number is prime. So we've looked at a lot of stuff. All right, good enough. All right, so let's move on to, we finished the introductory concepts. So let's move on and talk about fractions. What is a fraction? A fraction is part of a whole. What are the parts of a fraction? The top is called the numerator and the bottom is called the denominator. You also have the fraction bar. So you have the top, the fraction bar, and the bottom. The numerator tells us how many parts we have. The denominator tells us the total number of parts. So let's test our knowledge. What fractional part of algebra are A's? Now, what fractional part of? After of, this is the whole. So that's the total number of letters. Okay. That goes in the denominator. So that's 2, 4, 6, 7. And how many letters in algebra are A's? 1, 2. So the fractional part would be 2/7. Proper fraction. A proper fraction is when the numerator is less than the denominator. So here are some examples. 1/2, 3/4, 5/7, 8/9. Okay, these are proper fractions. Improper fractions. the numerator is equal to or greater than the denominator. So 11 over 11, that's a proper fraction. So the numerator is equal to 12 eighths. The numerator is greater than, okay? 13 fifths, 101 over 72. So these are improper fractions. All right, so a mixed number is a whole number and a fraction. This is the whole, this is the fraction. This is the whole, and this is the fraction. So this is a mixed number. Okay. Okay. So what I want to do is to take an improper fraction and change it to a mixed number. So let's do that. So let's take 24 fifths. That's improper. And we want to change it to a mixed number. So I say 5 into 24. 5 will divide 24 4 times. 4 times 5 is 20. We subtract and we get 4. Now, if we were dealing with whole numbers, we would say remainder 4. But we're dealing with fractions now. So we take this 4 and put it over 5. So that's 4 and 4 fifths. Okay. All right, let's do another one. 19 thirds. 3 are going to 19 6 times. 6 times 3 is 18. Subtract, we get 1, 6, and 1/3. All right, so let's reverse ourselves. So we want to change a mixed number to an improper fraction. And so let's just use the numbers that, let's take 4 and 1/5 and see if we get what we started with. All right, so 4 and 4 fifths is a mixed number, and we want to change it to improper. So we take the denominator and multiply it times this whole. 4 times 5 times 4 is 20, and then we add the numerator. That's 24 over 5. So let's look at it again. 4 and 4 fifths. 5 times 4 is 20, plus 4 gives me 24. All right, we had another one, which was 6 and 1/3. 3 times 6 is 18, plus 1 gives me 19 thirds. So that's how you change a mixed number to an improper fraction. All right. The next concept we want to look at is find the least common multiple of 4 and 6. So we're trying to find the smallest number that 4 and 6 would divide. 4 divides it, and 6 divides it. The smallest number that both of these would divide evenly. This is what we call the least common multiple. We want the smallest number that both will divide. Okay. All right. So let's look at method 1. Multiples. So the numbers are 4 and 6. So we just start writing multiples of 4. Now, what do we mean by multiples of 4? We start with 4 and keep adding 4. 4 plus 4 is 8. 4 plus 8 is 12. 4 plus 12 is 16. 4 plus 16 is 20. 4 plus 20 is 24. So the question is, when do you stop? Well, that's a good question. So I would recommend that you write down about 8 numbers, something like that. How many I have? 2, 4, 6. Okay, write down 7 numbers, and then I'm going to show you what you need to do. All right, start with 6, add 6, add 6, add 6, add 6, add 6. Okay. All right, after you write down about 8 numbers, 2, 4, 6, I got 7. We want to go through and scan these, and we want to start from the left and go to the right. And we want to zero in on the first number they have in common. That looks like 24, 24. Nope, that's not right. The first number they have in common is 12. Okay, so the first C, I went too fast. So you got to take your time and look. 12 and 12. All right, so 12 is the smallest number that both of these will divide evenly. See, I was going up to 24. It is true that 4 will divide 24 and 6 divide 24, but it's too big. That's not the smallest number. Okay. All right, let's continue. All right. Now, sometimes the numbers, can get big. I'm going to do the multiple method again. This is 14 and 24. All right, so this is 14, add 14, 28, add 14, 42, add 14, 56, add 14. So I need to make sure that I'm getting these correct, because otherwise it won't be right. That's 42, add 14, 56, add 14, that's 70. Add 14, that's 84. 1, 2, 3, 4, 5, 6. Let's add 14 again. 98. All right, let's do 24. Let's put that in a different color. All right, that's 24. Let's add 24. 48. Okay, I don't see that. Let's add 24 again. 72. Do we see it? No. Let's add 24 again. 96. I don't see that. If I add 24 again, that's 120. All right, so I need to add some more to the 14. So you can see this is getting big. Okay, so I need to go back to my 14. So this is 98, and I need to add 14 to, that's 112. I need to kind of get up to 120. So let's add 14 again. That's 126. All right, we seem like it's getting bigger. So 120, and I add 24, 144. 24, 86. 24, 192. All right, now I need to go back to my 14. Okay, that's 140. Add 14, 154. You're probably wondering, are we going to get there? I'm wondering the same thing. All right, so 154. All right, so that's 154. Add 14, 168. And 14, 182. Let me go back and check this. This is 190. Oh, woo, woo, woo. We got it right here. 168 right here. Okay. All right. So that is the smallest number that 14 will divide and 24 will divide. Okay. Now, you're probably wondering, gosh, Professor Hawkins, is there another way that we can do this? There is. So let's take a look at that. Okay. So we're trying to find the least common multiple of 14 and 24. Okay. And this is what I call method 2. And this is the LCM soup. Now, later on, we're going to call this the least common denominator because that's what it is, the LCM soup. Okay. So what we're going to do is take 14, use prime numbers. That's the first step to break the number down. Now, what do we mean by break the numbers down? So I'm going to take 14 and I'm going to use only prime numbers to divide. I'm going to say 2 into 14. Why 2? Because 2 will divide 14 and 2 is prime. I get 7. Now, you can only use prime numbers. See, it says use prime numbers. Okay. Then I say 7 into 7 is 1. When you get 1, you stop. Okay. All right. Now I'm going to do the same thing with 24. All right. Start with the lowest prime. 2 into 24, 12. If the prime number works again, use it again. 2 into 12, 6. 2 into 6, 3. And then 3 into 3, 1. So you stop when you get 1. Now, what do you do with this? This is what you do. Okay. I'm going to draw me a big circle here. This is my soup. All right. So the first thing, we use prime numbers to break the numbers down. Okay. Second thing, dump the first numbers prime into the soup. All right, this is my first number. The primes are 2 and 7. Let me stop so that you can see that. So you dump the first numbers prime into the soup. Okay. All right. What do you do next? Now, here you want to be careful. Okay. So 3. Look at the next numbers prime and see and do a number comparison. And do a numbers comparison of the primes in the soup. Now, what do I mean by numbers comparison? This is what I mean, okay? When we did 24, 24 looked like this. Okay? All right, 24 needs 3 2s. Okay? Let's look at the soup. 3 2s. The soup has 1 2. So I need 2 more 2s to take care of 24. So I put in 2. All right. That takes care of the 2s. 24 needs 1 3. I do not have a 3 in the soup. So I need to put a 3 in my soup. Okay. So the goal is this. Every number that you have, you should see the prime factorization in your soup. Okay. So let's see. 14. I see that right there. 24. 2 times 2 times 2 times 3. I see that, but I don't have too much. Okay. So what did we do? We just dump the first number primes into the soup. And then for all the other numbers, we list the primes that the number has and how many they have and see if we have that many in the soup. All right. So the primes for this number are 2s and 3s. I need 3 2s. I need 1 3. I look at my soup and see if I have 3 2s. If I don't, I have to make sure I do. I need 1 3. If I don't, I need to put it in. So this is my LCD. So let's see what this number is. It should be 168. Okay, let's see. This is 14. This is 14, and that's 12. So 14 times 12. That's 8 and 2. That's not good. So 14 times 12. 2 times 4 is 8. 2 times 1 is 2. 1 times 4 is 4. 1 times 1 is 1. 8, 6, 1. 168, and that is correct. Okay. So now, this might not be fast enough, but I think that with the LCD soup, um, I'm thinking that you have less stress because you know these are simple prime numbers right here, 2 and 7, 2, 2, 2, 2. And then you just dump the numbers in the soup, and then you compare the number of primes. Okay. And then if you don't have enough, you have to put a prime in the soup. Okay. So I hope that helps, especially when the numbers get big. All right, so this is what we call method 2, factor the numbers into prime factors. Dump the first set of primes into your soup. Go to the next set of primes, okay? Look into your soup and see if you have all the prime factors of the number in the soup. If you don't, put the prime factors in. Repeat until you have completed testing all sets of primes. Now multiply the numbers in the soup. This is the LCD. Okay, so you go to the next number and its set of primes. Look into your soup and see if you have all the prime factors of the number in the soup. If you don't, put the prime factors in. Okay. All right, good enough. So here's one. Find the LCM of 18 and 90. I'm just using the multiple method. So this is 18, 18, 36, 54, 72, 90. And we know 30, 60, and 90. So 90 is the smallest number. That's 18. The pen is skipping. And 30 will divide evenly. So 18 into 90, and then 30 into 90. Okay, so this is going to be 5, and this is going to be 3. So 90 is the LCM. All right, so I hope that helps, and I just need to finish this next week. So I think what I do is finish it in 2 parts. Okay. All right. So have a good night, and I'll talk to you later.